Hi everyone, this is Professor Lubimtseva from your GPY 100 Physical and Environmental Geography, and today I will talk to you about transient atmospheric flows and disturbances. This lecture has three learning objectives. First of all, to understand secondary features of general circulation of atmosphere, such as flows and disturbances. Second, we would learn about classification of air masses and fronts. And finally, we would learn the major characteristics of atmospheric disturbances such as mid-latitude cyclones, tropical hurricanes, and tornadoes. Let's start by defining what is an air mass. An air mass is a large body of air of relatively similar temperature and humidity characteristics, covering sometimes thousands of square kilometers, and they are defined by their geographic areas of origin. So air masses are classified according to characteristics of their temperature and humidity of the areas where they originate. Based on their source geographic region, air masses can be classified in one of these four major types based on their temperature: equatorial, tropical, polar, or Arctic, or Antarctic in the southern hemisphere. This is based on their temperature characteristics. Based on the moisture characteristics, air masses are classified into continental or maritime. Continental air masses form over continents, and maritime air masses form over the oceans. So combining these two categories, temperature and moisture, several possibilities can be found, and those are air masses that we typically experience in North America: maritime polar, continental polar, maritime tropical, continental tropical, and continental Arctic. This map illustrates the distribution of major types of air masses over North American continent. As you can see, the predominant air masses around us here in this area, of course, we are experiencing continental polar coming from northern Canada, as well as maritime tropical and continental tropical. Continental tropical originates over southwestern and southern parts of the United States and northern Mexico, and then maritime tropical is originating over Mexican Gulf and the Atlantic Ocean. The next important concept in this chapter are atmospheric fronts. So fronts are emergent when two air masses develop a sharp boundary where the temperature differences between them becomes intensified. Such an area of intensification is called a front or an atmospheric front. The boundary between the warm and cold air masses always slopes upward over the cold air. This is because warm air is always moving upward and cold air is sinking down. The sloping of warm air over the cold air leads to a forced uplifting, the so-called fronting lifting of the warm air, if one air mass is moving towards the other. This uplifting causes condensation, and this is leading to a possibility of precipitation along the frontal boundary. Fronts can be cold or warm. A cold front is a transition zone in the atmosphere where an advancing cold, dry, stable air mass displaces a warm, moist, unstable subtropical air mass. On a weather map, the cold front is drawn as a solid blue line with blue triangles. A warm front is a transient zone in the atmosphere where an advancing warm, subtropical, moist air mass replacing a retreating cold, dry, polar air mass. On a weather map, a warm front is drawn as a solid red line with half circles also painted in red. Frontal zones where the masses are not moving against each other are called stationary fronts. So stationary fronts are staying in place. So here is an example of atmospheric cross-section of a cold front. As you can see, the warm air is receding here and the cold air is advancing, and you can also see lots of cloud development because of frontal lifting of the warm, moist air over dry, cold air. And the cold air is shown on the map with this triangle symbols. And of course, the color of the line is blue. Here is an example of atmospheric cross-section of a warm front. As you can see, in this situation, it's the warm air which is advancing, and it's behind the warm front, moving upward, and the cold, dry air is receding. It is ahead of the warm front, and it's moving away. So here we see cloud development because of the frontal lifting of warm, moist air climbing over the surface of the cold, dry air. Now, sometimes an occluded front can be formed, and this is happening when a fast-moving cold front catches up and overtakes a slower moving warm front. This can actually happen quite often because cold fronts are typically faster than warm fronts. And so when this occlusion is happening, a cold type occluded front occurs when the air behind the front is colder than the air ahead of the front. When the air behind the front is warmer than the way ahead of the front, a warm type occluded front is produced. Warm type occlusions are common on the west coast of continents and are generally formed when maritime polar air collides with continental polar or Arctic air. So here is an example of atmospheric cross-section of an occluded front. As you can see, cold air ahead of the occluded front is receding here. The advanced, very cold air behind occluded front is then catching up with warm air, and the warm air is sort of stuck between the two cold air masses. Again, we see cloud development because of the frontal lifting of warm, moist air, and the occluded front would be shown on the weather map with a combination of blue triangles and red semicircles. There are three major types of atmospheric disturbances that I would like to introduce. These are mid-latitude cyclones, tropical hurricanes, and localized atmospheric disturbances such as easterly waves, thunderstorms, and tornadoes. Mid-latitude cyclones are very common in mid-latitudes, including here in the upper Midwest in Michigan. Those are large traveling atmospheric cyclonic storms up to 2,000 kilometers in diameter, with center of low atmospheric pressure in the middle. An intense mid-latitude cyclone may have a surface pressure as low as 970 millibars, compared to an average sea level pressure of 1,013 millibars. An individual frontal cyclones usually exist for about 3 to 10 days, on average a week, moving generally west to east. So they are moving from the Pacific Ocean over the Great Plains towards the Midwest. They regenerate over the Great Lakes, and then they move towards the Atlantic Ocean. And then this pattern continues over the Atlantic towards European continent, and they're moving all around the globe. The mid-latitude cyclones commonly travel about 1,200 kilometers in one. So these low pressure zones are following mid-latitudes between the high pressure centers in the Arctic and in the tropical areas. They are roughly associated with Rossby cells, and they are following the zone of the jet stream, or also the polar front between the Arctic and tropical air masses. So here on this map you can see areas of warm and cold fronts and occluded fronts as shown with blue triangles and red semicircles. This is an idealized diagram of mid-latitudinal cyclone. As you can see, the warm front is ahead of the system, the cold front is behind of the system. The cold front is catching up with the warm front, and then it can lead to occlusion. We see the warm air in the center of the system, and everything, of course, is revolving in the northern hemisphere in the counterclock counterclock direction because of the Coriolis effect. Another type of cyclonic systems are hurricanes. Hurricanes are very intense cyclonic storms, also associated with very low pressure, and they develop over warm oceans of the tropics. Typically, the warmer is the surface of the ocean, the higher is the amount of latent heat available for formation of hurricanes. So you are very aware that we have a very unusual, very intense hurricane system this year because the sea surface temperature is very high, and so there's lots of moisture, lots of water vapor, and lots of latent heat available for formation of hurricanes. Other names in various parts of the world for tropical hurricanes include cyclones in India and in Australia, typhoons in the western part of the Pacific Ocean, and Baguio in the Philippines. So those are just different local names for tropical hurricanes. By international agreements, the term tropical cyclone is used by most nations to describe hurricane-like storms that originate over tropical oceans. Relationship between surface pressure and wind speed for a number of tropical low pressure systems is illustrated on this graph. So you can see that tropical low pressure systems are classified as hurricanes when their pressure is below 980 millibars and sustained wind speeds are greater than 118 kilometers per hour. Differently from mid-latitude cyclones, hurricanes have no fronts associated with them. They are also typically smaller than mid-latitude cyclones, measuring on average 550 kilometers in diameter. Mature hurricanes usually develop a cloud-free eye at the center with very low pressure inside. In the eye, air is descending, creating clear skies. The eye of the hurricane may be 20 to 50 kilometers in diameter. Surrounding the eye are bands of organized thunderstorm clouds formed as warm air moves in and up into the storm. The strongest winds and heaviest precipitation are found in the area just next to the eye of the hurricane. We are going to look at some pictures of hurricanes, and I also encourage you to look into just the weather news of the past few weeks, as we are experiencing this year an unusual hurricane season, maybe only comparable to the hurricane season 2005. On these satellite images of tropical hurricanes, you can clearly see the hurricane eye with clear sky developing in the middle. This is another view of the hurricane eye. You can see essentially as a column inside of the hurricane without precipitation and without clouds. Hurricanes develop over oceans and are powered by the latent heat energy released from condensation. To form and develop, they must be supplied with a constant supply of warm, humid air that is necessary for this process. Surface air with enough energy to generate a hurricane only exists over tropical oceans with a temperature greater than 26.5 degrees Celsius or 80 degrees Fahrenheit. Hurricanes dissipate when the energy supply is substantially reduced. Most hurricanes live for about 1 week, and then they gradually dissolve. This map illustrates typical paths of mid-latitude cyclones and tropical hurricanes over the world. As you know, this year we're experiencing really unusual, extremely active hurricane season, so I would encourage you to watch this video on YouTube for a few minutes about the hurricane season 2020. Now let's talk about examples of some small local disturbances. You all are very familiar with thunderstorms. Thunderstorms form when moist, unstable air is lifted vertically into the atmosphere. The process to initiate vertical lifting can be caused by unequal forming of the surface of the Earth. It can be also caused by orographic lifting due to topographic obstruction of airflow when there is a barrier, for example, in the mountains. And it can be also caused by dynamic lifting because of the presence of a frontal zone. Generally, two types of thunderstorms are the most prevalent. Air mass thunderstorms happen in mid-latitudes in summer and also any time of the year on the equator. And thunderstorms associated with mid-latitude cyclone cold fronts, these types of thunderstorms often have very severe weather conditions that we are experiencing sometimes here in West Michigan. This map from our chapter illustrates an average number of thunderstorm days per year in the United States. You can clearly see that the highest number of thunderstorms is in Florida, and then as you are moving north and west, the number of thunderstorms is declining with no thunderstorms along the Pacific coast. Another type of local atmospheric disturbances are tornadoes. A tornado is a vortex of rapidly moving air associated with some severe thunderstorms. Winds within the tornado funnel may exceed 500 kilometers per hour, and the air pressure at the tornado center is approximately 800 millibars, way lower than inside of the cyclone or even tropical hurricane. So many human-made structures simply collapse outward when they are subjected to pressure drops of such enormous magnitude. Tornadoes, as you know, can be extremely destructive. The destructive path of a tornado is usually about half a kilometer wide and usually no more than 25 kilometers long. About 74% of all tornadoes have wind speeds between 65 and 181 kilometers per hour. And this concludes our lecture based on Chapter 7. Please email me if you have any questions or see me on Zoom. And don't forget to submit your quizzes that are due as usually Friday at noon by email. And I would see you next week.